Hello there my science friends and welcome back to my channel. Let's talk about one of the topics that I get asked all the time from colleagues and friends alike. How bad are artificial sweeteners really? Something that tastes sweet but has 0 calories is generally suspicious to a lot of people. And then you see and hear in the media all the time that artificial sweeteners can lead to cravings, overweight, cause diabetes type 2, or even worse, give you cancer. So all the things you really don't want when you opt for Coke Zero instead of full sugar Coke. But are aspartame, saccharin and co. really that bad? The short answer is yes and no. And the long answer, well, that will be this video. Let's get started. First things first, the basics. Artificial sweeteners are meant to replace sugar because a diet high in sugar increases the risk of overweight, diabetes type 2 and cardiovascular diseases. But replacing sugar is not that simple. First of all, sugar tastes really good, and the taste of artificial sweeteners doesn't even come close to that. Food manufacturers generally have little incentives to reduce the sugar content, and sugar is added almost everywhere as a cheap flavor enhancer. On top of that, sugar has, apart from its sweetness, some really important physicochemical properties. In ice cream, for example, applies the principle, the less sugar, the harder and less creamy the ice cream. Cakes and pastries also get dry if sugar is reduced. Hence why there is a whole palette of artificial sweeteners with different degrees of sweetness, but also different physicochemical properties to not only compensate for the sweetness of sugar, but also the whole mouthfeel, as they say. But then there are headlines that artificial sweeteners like aspartame or saccharin can cause cancer, but there is no reliable data for these claims. These concerns are indeed based on scientific studies. However, those were interpreted too hastily. After warning signs from animal and other single studies, detailed scientific research showed no correlation between artificial sweeteners and cancer in humans. Okay, so we don't have to worry about cancer from artificial sweeteners. But the other concerns? Yes, we should look at these in a little bit more detail. But for that, we need to understand how artificial sweeteners work. Artificial sweeteners are molecules that, exactly like sugar, bind on the sweetness receptors of our tongue and send the signal sweet to our brains. They often interact particularly strong with these sweetness receptors, which is why they are perceived as exceptionally sweet, even sweeter than sugar. But apart from the sweetness receptors on our tongue, the rest of the body can't really do much with most artificial sweeteners as they are not metabolized. This is called inert, which means they don't participate in chemical reactions. They pass through the body uninvolved, inert. Now, when no chemical reaction can happen with that artificial sweetener molecule, then no energy can be drawn from that molecule. Hence why artificial sweeteners like aspartame, saccharin, cyclamate, sucralose and so on have no calories. Side note. The artificial sweetener saccharin was first discovered by the chemist Konstantin Fahlberg in 1879. He was working on coal tar derivatives at the time when one evening he was licking his fingers and noticed a sweet taste. He claimed it on the compound benzoic sulfamide he was working with that day and later patented the compound as the artificial sweetener we now know and use as saccharin. Aspartame, on the other hand, was discovered by accident by the scientist James Schlatter in 1965. He was looking for a new anti-ulcer drug when he licked his finger to get a better grip for picking up a piece of paper and noticed the sweet taste. The aspartame that he tasted was a synthesized intermediate step during the synthesis of the hormone gastrin for ulcer treatment. I don't know what's going on with all these chemists out there licking their fingers and randomly discovering new artificial sweeteners. If you are a chemist out there, do not try this at home. Well, in the lab. Anyway, back to how they work. There are artificial sweeteners which can be metabolized and therefore have calories. These include sugar alcohols, so sorbitol, xylitol, maltitol, etc. These are used, for example, in dental care chewing gums. But it's not always all about calories, but also how our body directly reacts to sugar. Whenever we ingest sugar, to be exact, glucose, the glucose goes into the blood. The blood sugar rises. That's per se nothing bad, it happens after every meal. However, when the blood sugar levels remain permanently elevated, it becomes unhealthy, which is why our body releases a hormone called insulin. Insulin ensures that our blood sugar level decreases again. The worse this insulin response works, so the higher the blood sugar level, and the longer the blood sugar level remains elevated, the worse. With bad blood sugar levels, it could be a glucose intolerance, which means the body doesn't deal well at all with sugar. A glucose intolerance increases the risk of developing diabetes type 2. In diabetics, the insulin response doesn't work at all anymore, which means they have to inject themselves with insulin after every meal to lower the blood sugar levels. Which is why artificial sweeteners, which don't raise the blood sugar level, were not only recommended to diabetics, but it was also promised that artificial sweeteners used as sugar substitutes would reduce the risk of developing type 2 diabetes. So far the theory, but then? Let's have a closer look at this. Do artificial sweeteners increase the risk of type 2 diabetes and obesity? There are several hints about this in scientific research. Apart from animal studies, there is this little but very interesting American study. 17 overweight people took part. They gave all participants the same amount of glucose to monitor how strongly the blood sugar levels rise. But before this glucose shot, they gave some of the participants water to drink and some water with artificial sweeteners, water plus sucralose. And after artificial sweetener plus glucose, the blood sugar levels were higher than after only water plus glucose. And that's pretty outrageous, because really the artificial sweeteners should pass through the body uninvolved. But apparently it's not quite the same as only water. So really exciting results, but the study was too small. Could they not reproduce the study on a bigger scale over a longer period of time? Well, that's actually a really big problem for food scientists. You see, large food science studies fail for ethical and/or practical reasons. It is very hard to control what humans precisely eat over a long period of time. This would only work, for example, with people who live in aged care homes, but people who live in aged care homes are not representative of the whole population. Therefore, researchers can only look at big data sets and pursue the question, do people who consume a lot of artificial sweeteners also show a lot of diabetes or overweight? And the answer is yes, quite a lot of studies found this. But we have to be careful. This could mean that artificial sweeteners lead to being overweight, but it could also mean that overweight people tend to choose artificial sweeteners more often, which is actually obvious. And the same goes for diabetics, which is why caution is always required when interpreting food science studies, no matter for which food. But let's get to the bottom of this. 2016, this study on fruit flies was published. When fruit flies were given the artificial sweetener sucralose over a few days, they seemed hungrier afterwards. They consumed lots more calories than the control flies, which got regular sugar. On top of that, they got more hyperactive and slept less. If you can transfer this to humans is not clear yet. But this study shows, inert, so uninvolved, are these artificial sweeteners? Clearly not. They do something with the body. But what? What do artificial sweeteners do in the body? The answer could be in this study. The researchers observed mice that had either a normal diet or a high-fat diet, and they added either glucose to their water or glucose plus sweetener. They tested aspartame, saccharin and sucralose. And after 11 weeks, the mice with artificial sweeteners showed higher glucose intolerance. But the interesting part comes now. The reason for this seems to be in the gut of the mice. Just like in our gut, they have microorganisms living there, the intestinal flora, also called the gut microbiome. And while mice and humans don't metabolize artificial sweeteners, those ladies and gents do get going at it. Because when the researchers gave the mice antibiotics, which kills the gut microbiome, the glucose intolerance vanished. Apart from that, the researchers took some feces from the glucose intolerant mice and transferred it into sterile lab mice. Those are bred in a way to not have any gut bacteria at all. And after the transfer, the sterile mice also became glucose intolerant, which means the artificial sweeteners also led to a change in their gut microbiome, and with that to worse blood sugar levels. In fact, it is known for a while now that the gut microbiome of humans is extremely individual. It consists of lots of different bacteria, and the exact composition influences digestion, blood sugar levels, insulin response, and even appetite and fat storage a lot. Now, we are missing large human studies, but the researchers from that lab mice study did a pre-study with 7 healthy humans. They gave the 7 participants the maximum recommended dose of saccharin for 1 week. And after a week, 3 of the participants showed no effect, 4 of the participants showed, similar to the mice, a worse glucose tolerance. But we also know for sure that we can't just transfer food studies with animals to humans. It's simply complicated. Lab mice can not only be kept the same and fed the same, they are also genetically the same, or at least very, very similar. Which is very helpful when you want to study basic effects, for example, what happens when sugar gets replaced by artificial sweeteners. But the next question, or better to say the for us relevant question, is how does this affect our everyday lives? As humans, the differences in nutrition, environment and genetic factors are so big that one question like artificial sweetness, yes or no, is only one factor of many and therefore automatically carries less weight. In this fairly recent paper, the previous studies on artificial sweeteners and gut microbiome were reassessed and summarized. It says here, a change in the intestinal flora due to artificial sweeteners can only be seen in amounts of sweetener that are so large that they are not important for us humans and our diet. That's reassuring. Nevertheless, we can't rule out that even very small but long-term changes aren't critical. At the moment, we have no other choice than eagerly following the research on this topic. Right, and what now? What can we do with this information? As long as the research isn't concluded, should I now drink Diet Coke or not? For reals, artificial sweetness, yes or no? Well, the best way forward is probably this. Consume sweets only in moderation, whether sugar or artificial sweetener. There are 3 other reasons for this, apart from the previously shown hints. Number 1, free ride trap. Those who believe they do themselves something good with Diet Coke or sugar-reduced pudding easily fall into the free rides trap. Number 2, sense of taste. We seem to get used to a lot of things with regard to taste. There are a lot of personal reports that say the more sugar or artificial sweetener I consume, the less sweet I perceive fruits or other sources of sugar. And people that reduce sugar in their diet for a while all report at some point that the common chocolate bar from the supermarket tastes too sweet. There are a lot of self-experiments on YouTube nowadays, particularly in the Lent or Ramadan season. Have a look if you're interested. Anyway, what that means is if we're constantly overloading our sweet receptors with sweetness, we can indeed lose the appreciation and taste for healthy sweet foods. Number 3, where are the nutrients? Foods that are strongly sweetened, particularly those that are offered with sugar replacements with artificial sweeteners, are often very low in nutrients, so nutritionally worthless. Literally. Best example for this are soft drinks. Only calories, no nutrients. And with artificial sweetness, it's basically only emptiness. Healthy diet means to eat healthy nutrients, and you won't find them in foods like that. Artificial sweeteners are, according to the current research point of view, no worse than sugar. They help with the calorie and sugar reduction as well, although the side effects like the change in gut microbiome are still being studied. But less sugar is definitely a good thing. Most of us, me included, are far away from the official WHO recommendations. They say per day to not consume more than 50 gram or even better 25 gram sugar. That's not an awful lot. And artificial sweetness can help with that. But as I said before, the better way is giving it up completely and instead of drinking Diet Coke, simply choosing a glass of water. How about you? Do you like light, diet or no sugar products? Or are you a serious sugar muncher? Or do you think it's easy to give up sugar completely? Write it in the comments below. I'll see you back here in 2 weeks. Until then, stay sciencey. My science friends, the last video was slightly delayed. Why? I'm glad you asked, because I won an award. Shilium ranked 3rd in the Young Scientist Award at Fast Forward Science. And for that, I want to say a big thank you to all of you who subscribe to my channel, watch my videos, and leave me big thumbs up and coffee in the comments below. I'll see you in the next video, and until then, as always, stay sciencey.